Okay, so I'm going to attempt to do the final exam review, and I just blew up the review a little bit, so hopefully it's more visible. Every review question for the final exam, I just cut and pasted parts of reviews from earlier in the semester, so none of these problems are technically new, but there are many less problems on the final exam review than if you went back and did all the chapter reviews. So hopefully you haven't forgotten too much, or hopefully if you forgot, it comes back quickly. So question 1 wants to know if these sets are equal, proper subsets, or subsets that are allowed to be equal. And for this question, because every element in B, the A, the B, and the C, is in the A set, B is a subset of A, and it's considered a proper subset because it's not equal. So this is a true statement. It wouldn't be correct to say A is a subset of B because the D that's in A isn't in B. So having A to the left of a subset sign wouldn't be correct. It wouldn't be right to say that these are equal because they're not exactly the same. It also wouldn't be okay to say A is an improper subset of B, or a proper subset or equal. But it will be okay to say B is a proper subset or equal to A. So when B is contained in A, as questions A and parts A and B of this have, both of these can be true. The top one's only true if B is not equal to A. The bottom one is true if B is contained in A or if B is equal to A. B is going to have the same answer because B is just a proper subset of A. The two items in B are also contained in A. Any of the items with A on the left won't be correct because there are elements in A, namely the 1 and the 3, that aren't in B. So I'm not going to pick any of the choices with A on the left. I'm going to pick both the choices with B on the left. The top one, B is a subset of A. This one's only true if it's a subset that's not equal. And this one is true if it's a subset or if it's equal. For part C, these sets are equal, and the choice that says A equal to B is definitely right. And then the two subsets with the equal signs are also allow sets to be equal. So the A is a subset or equal to B. Because the sets are equal, they have exactly the same elements. This is also acceptable. And similarly, the B is a subset or equal to A. They're acceptable. The only ones that aren't acceptable is the B is contained in A but not equal, and the A is contained in B but not equal, because those two symbols there require the sets to be completely contained but not equal. So those won't count. Okay, that's the beginning. We'll see how this progresses. Number 2 wants me to construct a Venn diagram. I'll make the Venn diagram, but I might not use the Venn diagram to answer question 3. There's only 2 round sets I need to make. I'm drawing this rectangle to represent the universe of the numbers 1 through 8. And inside that rectangle, I'm going to make a circle and label it A. And then an overlapping circle and label it B. And I always fill the innermost part of the circles first. And in the very inside of the circles, I'm going to take the numbers that are in all the sets. In this case, it's 2 and 3. So I'm going to put a 2 and a 3 in the middle of my sets. Not that that looks like a 2 there, but that's supposed to be. So in that region where the sets are overlapping, I tried to draw a 2 and a 3, but it hardly shows up. So I'm done with those. I'm never going to have to place the 2 and the 3 again. Now I'm going to fill in the rest of A and the rest of B. A also has 1 and 4 in it that need to be in the A set but not in the overlapping part. I'm going to cross those out from the universe, cross those out for the A set. Now I've placed all the elements of A, 2 of the 4 elements from B. The other 2 elements that need to go in the B circle are the 6 and 7, and they go in the free part of the B circle, not the overlapping part. I'm going to cross those out. I've placed everything in the B set, and from the U set, I've placed the numbers 1, 2, 3, 4, 6, and 7. I just need to place the 5 and the 8, and I can place the 5 and the 8 anywhere inside the rectangle outside the circles. So that would be a Venn diagram that describes those sets. Now I'm going to answer question 3, but I'm probably not going to use the Venn diagram, although I could use the Venn diagram. A prime or A complement, this is going to be all the elements in U that aren't in A. So to find A complement, if I look at the U set contains the numbers 1, 2, 3, 4, 5, 6, 7, and 8. If I want to find the elements of U that are not in A, I'll just cross out the elements of A from the listing of U. And after I cross out the 1, 2, 3, and 4 that make up A, what I'm left with are the 5, 6, 7, and 8. A prime or A complement is going to contain the numbers 5, 6, 7, 8. They're the 4 numbers in the universal set that aren't in A. Part B asks me to do A intersection B prime. I'm going to write down what set A is. I know set A is the set that contains 1, 2, 3, and 4. I'm going to bring down my intersection sign. In B prime, I don't know what that is yet. B has the numbers 2, 3, 6, and 7. B prime has all the numbers in the universe that aren't in B. So 1 is in the universe, it's not in B, it has to be part of B prime. 4 is in the universe, it's not in B, so it's part of B prime. 5 and 8 are also in the universe, but not in B prime, not in B. So B is the numbers 2, 3, 6, and 7. That's 4 numbers. There's 8 numbers in the universe. The other 4 numbers that aren't part of B are in B prime. So B prime contains the numbers 1, 4, 5, and 8. And when I intersect 2 sets, I write what they have in common. So the answer to part B is going to be whatever these 2 sets have in common. Both the sets have a 1. Both the sets have a 4. And that's the only thing they have in common. So I'm going to say A intersection B prime just contains the numbers 1 and 4. Part C wants me to take A prime and union B prime. A prime is the set 5, 6, 7, and 8. Bring down my union symbol. B prime is the set 1, 4, 5, and 8. And when I union 2 sets, I write the entire first set and then anything that the second set has that it doesn't have. So the entire first set is 5, 6, 7, and 8. So that's good. Those 4 numbers have to be part of the union. And then I'm going to put any numbers in that I haven't already included. So for B prime, when I go to add to make the set bigger to form a union, I don't have to add 5 and 8 again because I've already added them. But I'm going to add 1 and 4. So the union is any number that's in the left set or the right set or both sets. And you can form the union by writing down the entire left set and then adding to it any number that you haven't already included in the right set. So in the right set that had 1, 4, 5, and 8, I already had the 5 and 8 in the union, so I didn't have to add it again. And I just added the 1 and 4. And I wrote the set in a nice order. But if you would have done something like this, if you would have did 5, 6, 7, 8, comma 1, comma 4, that would be completely fine. So had you just written the entire left set and with the numbers written first and then added what was missing from the B prime set, you'd get this answer. Both are equivalently correct answers for A prime union B prime. 3 wants me to make a Venn diagram. And again, it's something that we've done before. And this is about Taco Bell making 2 new burritos. One burrito is a pork burrito, the other burrito is a chicken burrito. I'm going to make a Venn diagram that breaks up the 100 people that were surveyed into the types of burritos that they preferred. So I'm going to make 2 circles. I'm going to make one for people liking the pork burrito, another circle for the people liking the chicken burrito, and I'm going to fill it in from the middle out. The 28 of the 100 people that liked both are going to go in the dead center. When we give you these problems, they're deceptive. The fact that it says 50 like chicken, of the 50 people that like chicken, 28 liked both. So if I take the 50 that like chicken and subtract the 28 that liked both, that's how I get the number of people that only like chicken, and 50 minus 28 is 22. That number is going to go right in here. So there were 28 people that liked both pork and chicken, 22 that liked chicken only. Similarly, the 40 that liked pork, some of them also liked chicken. If I take the 40 and minus 28, that's going to give me the 12 people that only liked pork. So of the 40 that liked pork, 28 liked both chicken and pork, 12 liked just pork only. If I look at the numbers in my Venn diagram now and add them up, I have the 12 that only liked pork but didn't like chicken, the 28 that liked them both, and the 22 that only liked chicken but didn't like pork. If I add these up, I get 62 people. I did that right? Yes. And there are 100 people surveyed. So of the 100 people, 62 of them liked one or both of the burritos. If I take 100 and minus 62, I'm going to get 38 that didn't like either the pork or the chicken. And that 38 can come out here. Now that I have the Venn diagram filled in, how many liked only pork would be this region of the Venn diagram, those 12. How many didn't like either? That would be that region of the diagram, that 38. Five wants me to make a more complicated Venn diagram that's going to have 3 circles. So part A says make the Venn diagram. And this 100 students were surveyed as to what classes they were taking. Some were taking math, some were taking chemistry, some were taking English, some were taking 2 of the 3, some were taking all 3, some were taking none of the 3. So I'm going to make a Venn diagram, and it's going to need to have 3 circles, one for each class that a student might be taking. I'm going to make a math circle, an English circle, and a chemistry circle. And your circles don't have to be in the same position of mine, but you need to have one of each. When we fill in these Venn diagrams, we go from the middle first. The region in the middle where all 3 circles overlap represent the 11 students that are taking all 3 classes. So I'll fill in that portion of the Venn diagram and then kind of work my way out from the middle on out. Here, the next thing I'm going to work on are these 3, and these numbers aren't going to go in the Venn diagram. Each one of these has to have 11 subtracted from it. 40 that are taking math and English, 11 of them are also taking chemistry. So to find out how many people are taking math and English but not chemistry, I'm going to take the 40 that are taking math and English and possibly chemistry, subtract out the 11 that are taking all 3, and that's going to give me 29. And in this region right here, the 40 that are taking math and English gets broken up. 11 are taking math, English, and chemistry. 29 are taking math and English but not taking chemistry. Similarly, the 19 that are taking chemistry and English, 11 of those are also taking math. If I subtract out the 11 of those that are also taking math, 19 minus 11 is 8. I'll get the 8 students that are taking chemistry and English, but not math. So of the students that are taking chemistry and English, 11 are also taking math, 8 are only taking chemistry and English. And for the last double here, I'm going to take the 24 taking chemistry and math and possibly English, subtract out the 11 of the people that are taking all 3 classes, and I'll be left with 13 people that are only taking chemistry and math and are not taking English. So of the 24 that are taking chemistry and math, 11 are taking all 3 and 13 are taking just the 2. Now I'm going to fill in the rest of the math circle. To fill in the rest of the math circle, I'm going to take the 60 and subtract any number that's in the math circle. The numbers in the math circle are the 13, the 11, and the 29. And when I add those, I get 29, 39, 40, 53. And 60 minus 53 are going to give me 7 students that are taking math and no other classes. To fill out the rest of the English circle, I'm going to take the 62 that are taking English and subtract any numbers that are already in the English circle. This 29, this 11, and this 8 that are in the English circle already, I'm going to subtract. 29 and 11 is 40 plus 8 is 48. So I'm going to go 62 minus 48. And I'm going to get 14 students that are taking English only. And the last thing I'm going to do is fill in the rest of the chemistry circle. 40 students are taking chemistry, but 13 of them are taking math but not English. 11 of them are taking all 3, and 8 of them are taking English along with chemistry but not math. And if I add these up, 13 and 11 is 24, plus 8 is 32. And if I subtract the 40 minus 32, I'm going to get 8 students for the rest of the chemistry circle. So now I have my circles filled up. I need to get a number outside the circle. To get the number outside the circle, I take the 100 total students and subtract all the numbers that I have in here. So there's a 7, a 29, an 11, a 13, an 8, an 8, and a 14. And I first break out my calculator for that. If I add those numbers up, I go 7 plus 29 plus 11 plus 13 plus 8 plus 8 plus 14. So of the 100 students, I've already taken into account 90 of the students. And if I subtract the 100 students that were surveyed minus the 90 that are already in the circles, I get 10 of the 100 students that aren't taking any of the 3 classes. So I have to have that Venn diagram more or less perfect to answer questions. And once I get the Venn diagram, the questions are generally easy-ish. So I have my Venn diagram. Now I'm going to use my Venn diagram to answer the questions. The first question is how many students are taking only chemistry? And should be listed B. A was the Venn diagram. I did that on the last page. For B, how many students were taking only chemistry? That's this region out here. That's the portion of the chemistry circle that doesn't overlap the other circles. So the answer to part B is there are 8 students that are taking only chemistry. Part C says how many aren't taking any of the 3 classes. That's these 10 out here. In part D, how many are taking exactly 2 classes? That's these 29 that are taking exactly the 2 classes, math and English. These 13 that are taking exactly 2 classes, math and chemistry. And those 8 that are taking English and chemistry. So for part D, I need to add the 29 that are taking only math and English but not chemistry, the 13 that are taking math and chemistry but not English, and the 8 that are taking English and chemistry but not math. And when I add those up, I get 50. All right, so that's the end, I think, of that chapter. And the next problems move on to the next test, our second test. So that's everything from the first test that we took this semester that might be test worthy. The next test had a bit of geometry, a change of bases, it had Roman numerals, and it had maybe some geometry stuff as well. The Pythagorean theorem is the a squared plus b squared equal to c squared, and I am going to assume, to do problem 1, that the side that's missing is the C, and I'm going to call the A 5. So I'm going to say 5 squared for the A squared, and then plus B squared. For the B squared, I'm going to write 12 squared, and I'm going to write equals C squared. 5 squared is 5 times 5, which is 25. 12 squared is 12 times 12, which is 144. So when I add these together, I get 25 plus 144 equals the C squared. 25 plus 144 is 169. So I get 169 equals C squared. And then I have to take the square root to find C. So I'm going to go second and hit the x squared key for my square root, type 169, and I'm going to get 13 equals C. And when I go to answer this, I'm going to write the C down with its units, and the units for this particular problem are meters. So the answer to this missing side, you could say C equals 13 meters, or you can just write 13. You could write an M for meters, or you can write the word meters out. So that's question 1. Question 2 wants me to find the perimeter. To find the perimeter of a triangle, you just add up the lengths. The lengths are 5 meters and 12 meters, which were the given lengths. And then the 13 meters is the length that I found out. If I add those numbers, I get the perimeter is 30. 5 plus 12 plus 13 is 30. And it's not square meters, it's just meters. You could write meters or just write the M. But you don't have to, the square would be wrong. You only get square when you get area. Question 3 wants me to do the area. This is a triangle. The area formula is half the base times the height. And in this particular triangle, the base is where the B is the 12 meters. The height is the A, which is the 5 meters. I don't need the 13 to compute the area. So in this case, the area is going to be 1/2 times 12 meters times 5 meters. When you multiply it, the meters times meters give you square meters. And then first thing I do is half of 12. Half of 12 is 6. Then I multiply the 6 and the 5, and I get 30 square meters. So answer to number 3 could be 30 meters squared, or you could write 30 square meters. So the number answers for 2 and 3 are the same. The units are different because in 2, it's perimeter, and perimeters don't get squares. In 3, it's area, and areas get square units. I'll write somewhere on the test all the formulas that I think you need, as well as any units that you need to have, so you don't have to waste your note card with formulas. I'll put those somewhere on the test. So question 4 wants me to find the volume of a box, and volume of a box, which is a rectangular solid, is length times width times height. And I have to figure out what I want each number to be. The tall, I'm going to call the height. The wide, I'm going to call the width. And then the depth, I'm going to call, I must have to call it the, 40 inches. I guess I'm going to have to call it the length. I don't have another letter for it. Maybe this wasn't the best choice of letters, but it kind of doesn't matter. To find the volume of a box, you just multiply the 3 dimensions. Here my length is 24 inches. The width is 24 inches. And the height is 40 inches. When I multiply, my units are going to be cubic inches. Inches times inches times inches. You could either say they're cubic inches for your units, or you can write an inch with a cubed. As for the number, I just have to multiply those 24 times 24 times 40. And my calculator tells me that's 23,040 cubic inches. So for an answer, you could write the volume is 23,040 cubic inches, writing the word cubic inches, or you can write 23,040 inches cubed. And you could even write the word volume if you wanted to. It would be probably nice. Or the V for volume would be also fine. Five wants me to find out how many gallons of water a pool can hold. And this is a two-step problem. First, I need to find the volume in cubic feet, and then I could use the unit to change from cubic feet to gallons. So the first thing I'm going to do is find the volume. And a pool is a rectangular solid. To find its volume, you just multiply the length times the width times the height. That's 24. It tells me it's the length. And I'm going to put feet down. And then 18, it tells me it's the width. And again, I'm going to put feet down. And 4 is the depth. I'm going to guess that's the height of the pool. So the volume of this pool, when I multiply 24 times 18 times 4, I get 1,728 cubic feet. Now I can use the unit that I have. The unit that I have says that 1 cubic foot of water is 7.5 gallons. So now I'm going to multiply by a fraction. The numerator is going to be the unit I want to get out. I want to get out gallons. The denominator is going to be the unit that I have. And I did a little slickness. Instead of writing cubic feet or cubic foot, I wrote a FT with a cube. That's the same thing as cubic feet. When I do this, the cubic feet cancel. The units that are left are gallons. And to get the proper number, because the 7.5 is in the numerator, I just multiply the two. So to finish this one up, if I take the 1728 and multiply it by 7.5, I'm going to get 12,960, and the units need to be gallons. So the answer to number 5 is going to be 12,960 gallons. Again, so any formula that you might need, the volume formula or the unit equivalents, I'll give you somewhere on the test. If not in the problem, I'll do a little chart on the test that will have all the formulas that you need. 6 wants me to convert a number in base 5 to base 10. To do this, I go backwards. I start with the first number, 4. I'm going to multiply it by the base to the 0 power. Then I put a plus sign. I take the second number, 1, and then I multiply it by the base to the first power. So to convert 14 base 5 into base 10, I take, going backwards, each number multiplied by 5 to some power. For the first multiplication, 5 to the 0 power is 1, because anything to the 0 power is 1. I'm left with 4 times 1, which is 4. In the second multiplication, 5 to the first power is 5, because anything to the first power is itself. Through the multiplication, I get 1 times 5 is 5. And the answer to 6a, 14 base 5 is equal to 9 base 10. Now for part B, I'll do essentially the same thing. I'm going to go backwards. I'm going to take the last number that I see, 6, multiply it by 7 to the 0 power, then put a plus sign. Take the middle number, 1, multiply it by 7 to the first power. Take the first number, 2, multiply it by 7 to the second power. Now I'm going to get rid of my exponents. 7 to the 0 power is 1. 6 times 1 is 6. Bring down my plus sign. 7 to the first power is 7. 1 times 7 is 7. Bring down my plus sign. 7 to the second power is 49. 2 times 49 is 98. Now I'm going to add those numbers up and get 111. So 216 base 7 is equal to 111 base 10. For me, it's easier to convert from a base into base 10, because you don't need to have any numbers kind of ahead of time. I just kind of work backwards. Here I started with the 4, then I did the 1. Here I went 6, 1, 2, and multiplied by each by the power of the base, starting at 0, working its way up. 7 wants me to convert into a base, and to convert to base 3, I have to know my powers of 3. 3 to the 0 power is 1. 3 to the first power is 3. 3 to the second power is 9. 3 to the third power is 27. 27 is bigger than the 12, so I'm not going to need that. My answer is going to have 3 positions. The first position is going to be for 3 to the second power. The second position is going to be for 3 to the first power. The third position is going to be for 3 to the 0 power. Now I'm going to start with my number 12, and I'm going to subtract. I'm going to subtract the biggest number that I see as many times as I can without getting 0, without going negative. So I'm going to subtract 9 one time. When I subtract 9 one time, I get 3. If I try to subtract 9 again, I'd get a negative number, so I'm done subtracting 9. And in my answer above the 3 squared, I'm going to write a 1 because I was only able to subtract it once. What I'm left with is a 3. Now I'm going to start subtracting the next power of 3. I'm going to subtract it once, and I'm going to get 0. If I subtracted it again, I'd get a negative 3, so that I only could subtract 3 to the first power one time. So above the 3 to the 1, I'm going to write 1. And then I'm done. So I'm done with the first 2 powers of 3. The last power of 3 I see is 1. If I tried to take this 0 and subtract 1, I'd get a negative, so I'm not allowed to subtract the 3 to the 0. I'm not allowed to subtract 1. So I'm going to get 0 times that I could subtract that. And so 12 to base 3, 12 is equal to 110 base 3. I'm going to do something similar for part B. I'm going to write down all the powers of 2 until I get over 115. So 2 to the 0 is 1, 2 to the first power is 2, 2 to the second power is 4, 2 to the third power is 8, 2 to the fourth power is 16, 2 to the fifth power is 32, 2 to the sixth power is 64, 2 to the seventh power is 128. 128 is too big. So my answer is going to have a bunch of digits. It's going to have a spot for how many times I could subtract 2 to the 6th, 2 to the 5th, 2 to the 4th, 2 cubed, 2 squared, 2 to the 1st, and 2 to the 0. Now I'm going to start with my 115 and start subtracting. The first number I'm going to subtract is 64. 115 minus 64 is 51. If I try to subtract 64 again, I'd get a negative, so I can't subtract 64 again. I only can subtract 64 once, so above the 2 to the 6th, I write the one time that I could subtract. Now I'm going to go to the next number in my list, which is 32, and subtract it. 51 minus 32, 11 minus 2 is 19. If I try to subtract 32 again, I'd get negative, so I was only able to subtract 32 one time. So above the 2 to the 5th, I write a 1. And now I'm going to start subtracting 16. 19 minus 16 is 3. If I try to subtract 16 again, I'd get a negative, so I was only able to subtract 16 one time. The next number I'd like to subtract is 8. But 3 minus 8 gives me a negative. I'm not allowed to subtract an 8. So above the 2 cubed, I'm going to write a 0. Couldn't subtract an 8. Now I'll see how many times I can subtract a 4. If I try to subtract the 4, 3 minus 4 is negative 1. I'm not allowed to subtract the 4 because I can't go negative. So the number of times I could subtract 4 is 0. Now I'm going to finally get to a number that I could subtract, which is a 2. I'm going to go 3 minus 2 is 1. If I try to subtract 2 again, I'd go negative. So I was able to subtract 2 to the first power one time. Done with that. And now I subtract the last number, which is 2 to the 0, and I was able to do it one time. My answer for this problem 115 convert it to base 2 is going to be 1110011 base 2. I didn't put any Roman numerals on the test, so you don't have to worry about those. Problems 8 and 9 are dimensional or unit analysis, and like I said, you don't have to know the units. In this particular problem, number 8, the 11 gallons of gas is a distractor. What this problem wants me to do is change 400 miles into kilometers, and to do that, I'm going to start with the 400 miles. I'm going to multiply by a fraction, and in the numerator it's going to be what I want. I want to find out how many kilometers I'm going, which I could write the word kilometers or abbreviate km, and in the denominator I want to put the unit of what I want to get rid of, which is miles. Could have wrote mile, probably would have been better. So I'm going to cancel the miles, my units become kilometers, and the numbers need to be multiplied because they're both, because the 1.6 isn't in the denominator. So for this problem, I'm just going to go 400 times 1.6, and I'll get 640 kilometers for my answer to question 8. Question 9, I needed 2 units. And to go from feet to meters, first I need to go from feet to yards. So the first thing I'm going to do is take the 120 feet and change it to yards, using the fact that 1 yard is 3 feet. And when I do this, the feet cancel, and I have to divide 120 by 3 because the 3 is in the denominator, and 120 divided by 3 is 40. So the first thing I did is took the feet into yards, and now I can use the unit that the author gave me, that 1 yard is 0.9 meters, and I'm going to multiply by the unit that I want in the numerator, which is the meters, divided by the unit that I have that I want to get rid of, which is the yards. My yards are going to cancel. Notice I abbreviated my units rather than writing yards and meters out. And now I'm going to multiply the 40 and the 0.9 because the 0.9 is not in the denominator, it's a multiplying. And 40 times 0.9 is 36. And the answer to this is going to be 36 m, or 36, I could write meters. This is a double unit analysis, although you might have been able to go from 120 feet to 40 yards in your head, and then just done 1 unit. That would be completely fine if you did that. 10 is also a double unit analysis. And I want to convert from square inches to square feet. Square inches are inches times inches. So what I have is 150 inches times inches, which are square inches. And I want to get into square feet, which are feet times feet. To do this, I'm going to multiply by 1 foot is 12 inches twice. Because I have to go from square to square, and the only unit I was given didn't have a square, I needed to do double. The first fraction is going to cancel out 1 of the inches. The second fraction is going to cancel out another of the inches. The units I'm going to have left are feet times feet, and feet times feet are square feet. So in my answer, I can write the word square feet, or a foot with an exponent sign. And then I need to divide by each, so I can go 150 divided by 12 equals, divided by 12 equals, and I get 1.04. And it didn't tell me how to round. On my key, I rounded to 2 decimals, so I'm going to leave it there. But if you gave me more decimals, I'd live with that. Another way to do this on my calculator, I just did 150 divided by 12 divided by 12. Still give me that same 1.04. So I need to divide by both of the 12s because they're in the denominators. On the test, I'll be more specific about how I want you to round. I was just looking at the key that I had, and the key that I had rounded to 2 decimals, so I just stayed consistent with that. 11's the money chapter, and that's using the TVM solver on the TI-83 or 84. So Alyssa's going to purchase a car, and that TVM money solver, I need to enter an N, an I, a PV, a PMT, a future value, a PY, and a CY, and I need to solve for something. Every problem on the test, the PY and the CY are going to be 12. So for Alyssa, she's making 60 payments. The N's going to be the number of payments, so I'm going to write 60 for N. The interest rate is 7.9, so I'm going to write 7.9 without the percent sign next to the I. The PV is the loan amount. In this case, her loan amount is $12,000. Trying to solve for the payment, so I'm going to actually alpha solve on that. I want the future value to be 0, and my payments per year and my compounding times per year are going to be 12. So when I go to my calculator, hit my apps button, finance, and enter, I'm going to type in 60 for the N, 7.9 for the I, 12,000 for the PV, 0 for the future value, 12 for the PY, 12 for the CY. I'm going to arrow up to the payment. It doesn't matter what it has in there. Mine had something in there that I did earlier. I'm just going to hit my alpha button and enter, and it's going to go over it. So Alyssa's payment is going to be, I'm going to round it to 2 decimals, is $242.74. For part B, determine Alyssa's balance after 2 years. After I've just computed her payment, I hit second and quit to get out of the screen. Hit my apps button again. Hit enter on finance, and then I need to find the BAL feature. And I'm going to hit the BAL feature, and I'm finding her balance after 2 years. If I multiply 2 years times 12 payments, that's the balance after 24 payments. So I'm going to do balance 24. And when I do that, I get her balance after 2 years, which is 24 payments, is $7,757.78. Again, to do that, I hit my apps button, the finance, and then I arrowed down to find the BAL. Hit enter on BAL, typed 24 because 2 years is 24 payments, and hit enter, and it gave me how much she owed, $7,757 after 2 years. Part C says she makes her payments for 2 years, and then she starts paying more. How much more time will it take to pay off? For part C, the N is what I'm going to solve for. Her loan is still the same loan, so she's still paying 7.9%. The PV is what she owes when she starts making her bigger payment. She's made her payment for 2 years. After 2 years, her $12,000 loan amount went down to $7,757.78. So in for her PV, I'm going to type the amount that she owes when she's making a bigger payment. Her payment is going to be bumped up from $242 by $100 to $342, and the payments generally have to have a negative number. So her payment's going to be negative $342.74 when I go to use my TVM solver. Still want to owe 0 in the future. Still making 12 payments per year. And the CY is still 12. I'm going to enter all those in my calculator and solve for N. So so I go apps, finance, enter. N doesn't matter what's in there, it's going to type over. 7.9 for the I, 7757.78 for the PV, negative 342.74 for the payment. Future value is 0, PY and CY are 12. I'm going to arrow up to the N and hit alpha enter. It's going to tell me she needs 24.59 more payments. So it's going to take 24.59 more payments. And each payment's a month. So that's about between 24 and 25 months. So I can say 24 to 25 more months. And that's just a bit over 2 years. So 24.59 months, 24 full payments, and then the last payment's going to be a little bit less than the $342.74. If you said about 2 years, that would be a good answer. If you said between 24 and 25 months, that would be fine. If you're at 24.59 and round to 2 decimals, that would be fine. Something so I could tell that you have the right keystrokes, and then your rounding I'm kind of a little flexible with. Make sure that all showed up on there. So for the answer to the last part, 24.59 months, 24 to 25 months, or a little more than 2 years are all acceptable answers. 2 talks about Beth borrowing for a truck. She's taking a 6-year loan. Her end's going to be 72, which is the 6 years times 12 payments per year. I can write 6 times 12 in for the N, or 72. I'm just going to use the TVM solver again. The interest rate she's paying, I'm going to write 4.9. The PV's her loan amount, which is going to be $36,000, so I'm just trying to compute best payment. Her payment's what I'm solving for. In the future, she's going to want to owe 0. And every money problem on the test, the PY and the CY, when we use a TVM solver, is going to be 12. So to compute best payment, I type in 6 times 12, or 72, into the N, 4.9 in for the I, 36,000 in for the PV, 0 for the future value. The PY and the CY are 12. I arrow up to the payment. Doesn't matter what's in there. My calculator's going to type over it. Hit the green alpha button and enter. And I get her payment's going to be, and I'll round it to 2 decimals, $578.11. To do part B, how much interest does she pay? I don't need the TVM solver. First thing I do is I'll make her total payments. She's making 72 payments of $578.11 if she makes every payment on time, doesn't miss a payment, doesn't double up. So her 72 payments times $578.11, she's going to pay in total $41,623.92 are going to be her total payments. But the truck she only borrowed $36,000, so the difference between what she's paying in her payments, the $41,623.92, minus the $36,000 that she borrowed, that's going to give me how much interest she paid. So I'm going to take the 41,623.92 minus the 36,000 that she paid for the vehicle, or borrowed for the vehicle, and she's going to have $5,623.92 in interest that she's going to pay. So the answer to part B is the total interest that she pays is this $5,623. And for part A, her total payment is $578 a month for 6 years. I think we're done with chapter 11 now. Chapter 12 is what we just did. Hopefully that's moderately fresh. I'll write down anything you need to know about cards on the test somewheres. And problem 1 is taking one card from a deck of cards. Each of the probabilities is going to have a 52 in the denominator because there's 52 cards. The numerator is going to have the number of cards that have the look that we need and how many cards are not red. There's 26 red cards, the diamonds and the hearts. There's 26 cards that aren't red, the spades and the clubs. So there's 13 spades and 13 clubs. There's 26 cards that aren't red of the 52 cards. 26 and 52 is a non-reduced answer. The probability of getting a card that's not red is 26 and 52, which reduces to 1 and 2. I'd live with either a reduced or a non-reduced answer. The probability of getting a single card that's simultaneously a 7 and a spade, the only card that fits this is the 7 of spades. There's only one card of the 52 that is both a 7, that is the 7 of spades. So the probability for part B is going to be 1 in 52. For C, the denominator is going to be 52 because I can pick any one of 52 cards. And then for the numerator, I want to find out how many cards in the deck are either a 6 or a spade. And I know that there's 13 spades and 4 sixes. The numerator for this fraction isn't going to be 17, because if you wrote 17, you've counted somewhere in here, in these 13, there's the 6 of spades. So if you say that there's 13 spades and 4 sixes, so the probability of getting a 6 or a spade is any one of the 17 cards, the 13 spades and the 4 sixes. You counted the 6 of spades twice. I can't count the 6 of spades as a separate card when it's only one card. So I'm going to take the 13 spades, which include the 6, and the extra 3 sixes that aren't spades. The probability of getting one of those cards, something that's a 6 or a spade, is 16 in 52. And then I'm going to reduce that fraction by 4 to get 4 and 13. And I'd live with either 16 over 52 or 4 and 13. I prefer you reducing, but it's honestly not that big of a deal if you don't reduce. Part D, again, the denominator is going to be 62. The numerator is going to be the number of cards in my deck that are both red and aces. And the cards that are red aces are the ace of diamonds and the ace of hearts. So there's 2 red aces in the deck out of the 52 cards. So the probability of getting a red ace is 2 in 52. And when I reduce this, it's going to reduce to 1 in 26. So either 2 in 52 or 1 in 26 are going to be acceptable answers. The next problem, I'm picking a single marble from a bag of marbles, and there's 11 marbles total, 6 black, 2 red, and 3 white. Each of my probabilities is going to have 11 for a denominator, because when I'm picking one marble out of a bag with 11 marbles, there's 11 different marbles that could come up. The numerator is going to have the number of marbles that have the desired look. For part A, the numerator is going to be 6, because there's 6 black marbles in that bag. And in the and for part B, I can accept a red or a white marble, and there's 2 reds and 3 whites, so the probability of getting a marble that's red or white is going to be 5 and 11, the 5 marbles that are either red or white. Question 3 needs a Venn diagram to answer the probability questions. And to do this, I'm going to make a tree. I'm going to start off, the first child could be a girl or a boy. And then whatever happens on the first, the second child could be a girl or a boy. And then whatever happens on the first 2, the third child could be a girl or a boy. I'm going to cheat and only do one branch, because I'm going to run out of room if I try to do both branches. And then I'll be slick to get the, well, I guess I can do all the branches, I guess. I guess I don't have to be slick. So the fourth child can be also a girl or a boy. So I'm going to need to go from the top of this tree down to each of the 16 items on the bottom to get my sample space. Not that that's hardly readable. So to get to this G, I need to go girl first, girl second, girl third, girl fourth. So one of the items in my sample space is have a girl, 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 and girl, all 4 child for girls. Now I'm done with that. I'm going to get to this. To get to this, it's going to be a girl for first kid, a girl for the second kid, a girl for the third kid, and a boy for the fourth. Done with that, which makes me done with that. To get to this G, I'm going to have a girl first, a girl second, a boy third, and a girl fourth. To get to that B, I'd have a girl first, a girl second, a boy third, and a boy fourth. Done with that and that and that. Now I'm going to go this way, having a girl first, a boy second, a girl third, and a girl fourth. Done with that. To get to this one, it's a girl first, a boy second, a girl third, and a boy fourth. Done with that and that. To get to the next one, it's going to be a girl first, a boy second, a boy third, and a girl fourth. And the last one is going to be a girl first, a boy second, a boy third, and a boy to the fourth. That takes care of this half of the tree. I can do exactly the same thing for the second half of the tree, or I can be slick. I'm going to take these 8 elements and write down everything the same except change the first kid to a B. So this all girls is going to convert to boy, girl, girl, girl. This girl, 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 boy, I'm going to make it now boy, girl, girl, boy. Just taking all these firsts and changing them to B's. That's a slick way to do the sample space. So my third was a G and then G, B, G. And so I'm just writing down each of the elements, hopefully doing them properly. So between these two columns, there's 16 items. Each of the probabilities is going to have a 16 in the denominator. Part A wants the probability the couple has all boys. And of the 16 different items in the sample space, only one of them is all boys. For part B, the probability that they have at least one girl, which is basically 1 girl, 2 girls, 3 girls, or 4 girls. All of these 8 at least have 1 girl. Some of them have 2, 3, and 4 girls. And all of these, except the bottom one, have at least 1 girl. There's only one item in the sample space that doesn't have at least 1 girl. That's the last one. 15 of the 16 either have 1, 2, 3, or 4 girls. So every single item in this column and 7 of the 8 in this column have at least 1 girl. Some of them have 2 girls, some of them have 3 girls, some of them have 4 girls. So the probability is going to be 15 and 16. And then for the youngest being a girl, I'm making this my youngest. So there's 1, 2, 3, 4, 5, 6, 7, 8 of the 16 have the youngest child as a girl. And I'm going to reduce that to 1/2. Another card problem with replacement. I'm drawing 2 cards. I'm going to multiply 2 probabilities together, and I'm picking a card, putting it back, and then picking another card. Each of the probabilities for each card is going to have a 52 in the denominator because a deck of cards has 52 cards, and for these particular problems, I'm picking a card from the 52, putting it back, and then picking another card. So what is the probability that both cards are black? The probability that the first card is black is 26 and 52 because there's 26 black cards, 13 spades and 13 clubs. The probability that the second card is black is 26 and 52 because there's 26 black cards. If I reduce each of these fractions and multiply, it's easier. 26 and 52 is equal to 1/2. So this problem is really just 1/2 times 1/2, and the probability of getting a black first and a black second when I'm replacing a card is 1 in 4. For part B, I'm multiplying 2 fractions with 52s in the denominator because on each choice there's 52 cards that I might get. For the first card, I need it to be a spade. There's 13 spades in a deck of cards, so the probability of getting a spade first is 13 and 52. Put the card back. My next card to be a heart. The probability of getting a heart next is 13 and 52. If I reduce these, this is going to be 1 in 4 times 1 in 4, and the probability of getting a spade first and a heart second is going to be 1 in 16. C again is going to have 2 fractions that have 52 in the denominator because I'm putting the card back. Each time I pick a card, there's 52 cards to choose from. The first card needs to be a 7. There's 4 7s in the deck of cards. Second card needs to be a 4. There's 4 4s in a deck of cards. If I reduce these fractions to 1 in 13 times 1 in 13 and then multiply, I'm going to get 1 over 169. So the probability of getting a 7 first and then a 4 second is 1 in 169. For 5, both of these are conditional probabilities, and I need to only look at the portion of the sample space that fits. So I'm going to roll 2 dice. What's the probability that the sum of the dice is 10 if the first dice is 4? I need to look at the portion of the sample space that has the first dice of 4. So I'm just going to write down not the entire sample space, but the portion of the sample space that's appropriate for this particular scenario. And in the sample space, there's normally 36 combinations of first dice, second dice. But for part A, I'm told that the first dice is a 4. The probability answer to 5A is going to have a 6 in the denominator. And because there's 6 things in the sample space that have a 4 first. And in the numerator, I added the numbers up, and I will need to find any of the pairs that have the dice adding up to 10. In that case, it's going to be a 1. There's one of the 6 things that could have happened that the dice add up to 10. B is similar. I need to write the portions of the sample space, the portion of the sample space that is appropriate. And in part B, I'm told that the second dice is a 2. When the second dice is a 2, the first dice can be any of the numbers 1 through 6. So what's the probability that the sum of the 2 dice is even, given that the second dice is 2? The denominator is going to be 6 because there's only 6 elements in the sample space that the second dice is a 2. Now I'm going to add up all the pairs. And I want the sum to be even. A 2 and a 2, a 4 and a 2, and a 6 and a 2 are the 3 items in this portion of the sample space where if I sum the dice I get an even number. So the answer for part B is 3 and 6, or I could say 1 and 2. So that's the end of chapter 12. Now we go to the chapter on mean, median, and mode and bar graphs. I didn't have any graphs put on the test. To do mean, median, and mode, mean I add up the numbers and divide, and there's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 3, 6, 9, 2. So for the mean, I'm going to add up all the numbers and divide by 13 because there's 13 numbers. Dangerous for me to add these without a calculator, so I'll do them with my calculator. So 2 plus 2 plus 2 plus 3 plus 4 plus 6 plus 7 plus 8 plus 9 plus 10 plus 11 plus 15. The numbers add up to 79. Now I'm going to take 79 and divide it by 13, and I get the mean. And again, it doesn't tell me where to round, which is kind of unfortunate. On my key, I have 6.69. Let me do these again. 2 plus 2 plus 2 plus 3 plus 4 plus 6 plus 7 plus 8 plus 8 plus 9 plus 10 plus 11 plus 15. Hoss. Now I get 77. That's 2, 4, 6, 9, 19, 26, 34, 42, 51, 61, 72. I get 87 if I add them by hand. 87 divided by 13 is 6.69. I obviously made some mistakes, so I'm adding. Let me try to get that 87. 2 plus 2 plus 2 plus 3 plus 4 plus 6 plus 7 plus 8 plus 8 plus 9 plus 10 plus 11 plus 15. There's the 87. So 87 divided by 13. On the test, I'll tell you how far to round. I don't see any instructions here. My key had 2 decimals, so I just rounded to 2 decimals. So that's the mean. I'll do the mode. It's easy. The mode is the one that occurs the most. And there's 3 2s and not more than 3 of anything else. So the mode is going to be 3. The mid-range is also another easy one. You just add up the highest and lowest and divide by 2. The lowest number is 2. The highest number is 15. This is going to give me 17 over 2. And 17 over 2 is 8.5. And the last one I need is the median. The median's the middle number. The numbers are listed from high to low. So I'm going to cross off first number, last number, second to the second, second to the last, third number, third to the last, fourth number, fourth to the last, fifth number, fifth to the last, sixth number, sixth to the last. Looks to me like the median, the number in the middle is 7. So for number 1 from the chapter 13 review, there's the 4 answers that you need. Two wants to know what grades Jess needs. I'm going to add up all her test scores so far, hopefully add them up properly. So far she's got a 90, plus a 70, plus an 88, plus a 71, a 42, a 98, and a 77. I think if I add up all her tests, they're 536 points. Let me do it again just in case, because clearly I'm having issues here. Yeah, so she's got 536 points. An average of 70 on 8 tests she needs to pass. So to pass, your 70 tests have to your 8 tests have to average 70 points each. If I take the 70 that you need to average times the 8 tests that you need to average that on, this is going to be the total points needed for a C, or needed to pass. I guess I would consider a C passing and not a D. So anyways, you need 560 points to pass. Jess has 536. If I take the difference between 560 and 536, that's how many points she's going to need to get her passing grade. So she needs 24 points to pass. To get a B, you need to average an 80 on the 8 tests. So the number of points necessary to get a B, I take 80 points times 8 tests. That's 640 points needed for a B. If I subtract the 536 points that she has, that's going to give me how many points she's going to need to get a B. And this is going to give me 104 points for a B on the last 8th test, which means you might need some extra credit or some sort of curve to get there. So one last problem on the test, or on the review, and the standard deviation I'm going to do on my calculator. It asked me to do range and standard deviation. The range is just the highest minus the low score. For this set of data, the range is just 11 minus 4, which is 7. The standard deviation, I'm going to use the stat feature on my calculator to figure out the standard deviation. To do this, I hit the stat button on my calculator, hit enter, and then I'm going to go up to the top of my list and hit the clear button and hit enter. It clears out the data. Fill in the list with 4, 7, 6, 5, 9, and 11. Second and quit. So what I did there is hit my stat button, hit enter and edit, went up to the top of the list, hit the clear button and hit edit to clear it, typed in my data, 4, enter, 7, enter, 6, enter, 5, enter, 9, enter, 11, enter. Have the data in. Once I have the data in, I hit the second button and the quit to get out of this data entering mode. Then I hit my stat button, arrow once over to calc, hit enter twice on one variable stats, and the number that I need, I don't believe I took the, my key says 3.56, but I'm getting 2.60. Let me check my data again. So stat, edit, 4, 7, 6, 5, 9, and 11. Looks perfect. Just try to type it again to make sure I haven't messed up. So 4, 7, 6, 5, 9, 11. Second quit, stat, calc, enter on one variable stats, enter again. I get 2.6. This SX is the standard deviation. I'm going to write 2.61. My calculator gave me 2.607. I'm going to round that to 2.61. On my key, I wrote 3.56, which kind of troubles me. I'm going to just go change my key because I did this twice and don't see a mistake. So I believe that 2.61 is the correct answer. Oh, maybe I'll go back to my office and do it by hand and make sure that I haven't messed up. So it should be everything that you need for the review. It's definitely, you know, a pretty involved review because it covers so much diverse material. You can use a note card on the test, and I'll give you any formulas and things that I think you need. So I'll tell you, how many feet are in a mile if that's what you need, or I'll give you the Pythagorean theorem. I'll give you the volume formulas that you might need. So you won't have to memorize any formulas or use your note cards for formulas.